In this projectile problem, we're asked to figure out this initial velocity that a basketball player shoots a basketball at. We're given the elevation it's shot at. It's shot at a 30-degree angle, and it's shot at a 10-foot basket. We're given the total distance from the basketball player to the backboard, and we're given the distance that we're trying to find out. We're given the distance that the ball is going to go to. It's 9 inches away from the back of the backboard. This was part of a two-part problem that switched this distance up a little bit, but we're just going to do this first part of the problem. So what this is saying is the basketball will hit 9 inches away from the back of the backboard. So this distance right here, from here to here, is going to be 15.25 feet after we subtract this 9 inches out. Okay, so if we have an initial velocity, and this initial velocity is v naught, it's going to have these two components. It's going to have a v naught initial velocity in the x direction, and it's going to have an initial velocity in the y direction, and that's right here. And since we know this angle, it's 30 degrees, we know that the v naught in the y direction is going to be equal to the magnitude of v naught times the sine of 30, and we know that the v naught in the x direction is going to be equal to v naught times the cosine of 30. Even though we don't know what v naught is, we can still come up with these two expressions. What else do we know? We know that our initial x position is 0. Our initial y position is 6.8 feet above the ground. And we know our final y position, right? So our final y position is going to be 10 feet. That's when the basketball hits the rim. So our final y position is 10 feet. And we also know our final x position. Our final x position is going to be 25.25 feet. So that's from right here to right here. So that's how far it travels in the x direction. 15.25 feet. What else do we know? Well, it's a projectile problem, so we're going to have an acceleration. Our acceleration is going to be due to gravity. So our acceleration is minus 32.2 feet per second squared. Now we have two velocities, all our positions, and acceleration. We don't know the time, and we're going to be looking for the time. But since we know all this, we can look at our horizontal and our vertical equations, and we can start with a horizontal equation. So our final, well, we have an x final is equal to an x initial plus an initial velocity in the x times t. We know everything except t, because we can substitute an expression for v naught x. We can substitute in numbers for x final and x initial. So let's do that. When we do this, we have an x initial is 0, so our x final is 10. Our x final is 15.25. Our v naught x is equal to v naught times the cosine of 30, and our time is unknown. So we still have t. We can figure out an expression for t. Our expression for t is 15.25 divided by v naught times the cosine of 30. So now we have an expression for time. If we look at our vertical equation, we can use the equation a final y position is equal to an initial y position plus an initial velocity in the y direction times time plus 1/2 times the acceleration times t squared. And what do we know here? Well, we know a final position right it's 10 feet. Initial position, it's 6.8 feet. Initial velocity in the y direction, we have an expression for that. We know time, and we know acceleration. So we can plug everything into this equation, we can solve for v0, and we'll have our answer. And if we do that, we have 10 right here is equal to our initial, so 6.8, plus our v0, our y component of velocity is v0 y is equal to v0 times sine of 30. So v0 times sine of 30. And we want to substitute in for t the expression we just found. So we get t is equal to 15.25 divided by v0 times the cosine of 30. And if we keep going, we get plus 1/2 times that minus, this is not 9.81, this is minus 32.2 times this expression for t squared. So 15.25 divided by v0 cos 30 squared. Now you can either put this into some numerical solver and get a expression for v0 right from this equation, or you can simplify it up a bit. I'm going to simplify it up a bit, and when I do that, I get 10 minus 10 is equal to 6.8 plus this v0 cancels with this v0. I get a tangent of 30 because of sine of 30 over a cosine of 30, plus 15.25 tangent of 30, plus 1/2 times 30 minus 32.2 times 232.56 over v0 squared cosine of 30 squared. And again, we can clean this up a bit. So we can subtract the 6.8 and the 15.25 tangent of 30 to the other side, and we get 10 minus 15.25 tangent of 30. Don't forget the 6.8 minus 6.8 is equal to minus 16.1. 16.1 times 232.56, so it's minus 4,992.3 over v0 squared. And if we solve for v0, we're going to get v0 squared is equal to 890.68 feet per second. So our v0, if we take the square root, is equal to 29.8 feet per second. So this initial velocity means you have to shoot the basketball at an initial velocity of 29.8 feet per second at a 30-degree angle to have the basketball hit the rim 9 inches away from the backboard.